Good afternoon, ladies and gentlemen. My name is ElsDuBois, and in this short movie I want to explain my paper on surrogate-based prototyping. I hope you enjoy the TMCE. Due to my pregnancy, I was not able to join you. However, I do want to try to entertain and inform you with this movie. First, I want to give some more background information about who I am. I am an industrial design engineer, and I finished my PhD research in October last year at the TU Delft in the Netherlands. Currently, I'm working as a postdoc researcher at the University of Antwerp in Belgium. This paper is about the last part of my PhD research. During this PhD research, I developed a designerly methodology for software development, which supports the interaction with stakeholders throughout the whole development process. The aim of my PhD was to increase the stakeholder involvement in the software development process in order to achieve better suiting products. To achieve this, we based on the principle of product development of consumer durables. Our hypothesis was that software development could benefit from product development as it intends to bring products closer to stakeholders. We investigated the whole development process. I identified 3 critical phases. These phases were examined during my PhD research, and this paper is focusing on the last phase, which is the system development phase. To support stakeholder involvement in this detailed design phase, we developed a methodology which we called surrogate-based prototyping. Having the aim of achieving higher quality with complex software products, we needed to pay attention to the importance of an all-aspect system development and testing before code production. The methodology of surrogate-based prototyping supports the development of a high-fidelity rapid prototype that is needed to test the functionality, usability, understandability, operability, learnability, attractiveness, etc. of the design software. In order to properly evaluate the current situation, we investigated the existing trends in the software industry. During this examination, the 4 most dominant software development paradigms perfectly show the evolution, as you can see. These are function-oriented development, object-oriented, component-oriented, and service-oriented development. We observed an increased complexity and flexibility of the software products. To respond to these, a need emerged to split the software concept into manageable parts, the so-called concept of separation of concerns. Software concerns are combinations of functionalities which are logical, structural, and from a user perspective separable. Considering the growing flexibility and complexity, the conventional methods are not ideal. Consequently, we focused on component-based and service-oriented software development to see how prototyping can be conducted. The methodology of surrogate-based prototyping uses the principles of component-based software development as enabler. Using a combination of existing software reduces the effort and time needed for original code development and offers the opportunity for faster functionality and utility testing. We assume that surrogate software can be used to simulate different application functionalities or concerns. By combining different surrogates, the whole functionality of the software can be prototyped and simulated. To ensure a working system, these surrogates must communicate with each other, and this might bring up a problem of interfacing. Considering the availability of software products on the market, we can assume that there are enough software surrogates available on which you can build the prototype. Based on the principles I just explained, we developed a detailed methodology of surrogate-based prototyping, including an underpinning theory, a detailed procedure, and methods and techniques that can be used. I will try to shortly explain these by using an example. If you are interested in the theoretical explanation, please take a look at the paper. The case we use is a complex interactive software tool that supports designers in smart energy saving using ubiquitous controllers. Current electronic household appliances are not optimal in terms of energy efficiency. and despite the existing technologies to optimize them, it is hard for designers to know what sensors and what actuators are useful in their products. This software aims to support designers in finding the best energy-saving solutions at an achievable cost. The case was used as a reference case throughout my whole PhD research. So in this phase we wanted to know how it works, what amount of data was needed, how the functionalities work together, and what the performance was of the software we developed. The first and most important step in the process of surrogate-based prototyping is the selection of the surrogates. To select the surrogates, the first step was to identify the software functions. As a basis for this, an interaction diagram that was developed in the previous phase could be used to develop the detailed story of how the software acts and interacts. These functions were collected in a functional decomposition scheme, as you can see here. Next, potential surrogates had to be found. This was a hard task due to the unlimited amount of potential software products that are available. Therefore, we first had to select the best resources. We decided to use a platform-based approach. This means that we wanted to use a platform that supports the communication among different software components that were designed to work on this platform. Based on our investigation, we found that Drupal was a good platform for our platform-based surrogate software prototype. In short, you can compare Drupal with a Lego kit, for which about 20,000 building blocks are available to create an online web application. This can be a website, a social network, a blog, a wiki, a web shop, or something else. The use of this platform shortens the development time by enabling automatic interaction between the models compared to when they have to be adjusted manually. Next, we try to match the functions with the affordances on the different modules in order to find the highest functional coverage with the least amount of gaps. On the slide that is shown here, the compliance matrix shows which modules are covering which functionalities. We selected a combination that needed the minimal amount of modules in order to simulate all or at least most functionalities. Next, we had to convert the functional structure of the software into meaningful data interaction schemes that show the software from a content view. At the end, you end up with a multi-level data scheme, as you can see here. It is showing the data that is defined, processed, and converted in the software product. And based on this data level scheme, the prototype was constructed. As you can see, this is just a screenshot to show you how the prototype looked like. This screenshot shows how a new product case can be generated at the start of a new project. And this screenshot shows how the software enables to search for energy-saving solutions. Based on this prototype, functionality and usability testing could be achieved. Based on the prototype, we learned that we had to improve certain parts before finalizing the complete software and before generating the code. To end my presentation, I want to give you a quick overview of the surrogate-based prototyping methodology. The methodology aims to increase stakeholder involvement in the system development phase by supporting the development of a testable prototype. This prototype should be composed by a combination of existing software surrogates and can be used for functionality and usability testing. I hope you did not run away during this movie, and I would like to thank you for listening. Unfortunately, I'm not able to answer any question in this format, but if you do have questions, please do not hesitate to contact me using this email address. Or if your question is very urgent, you can always have a chat about it with my supervisor, Professor Imre Horvat, who is also the organizer of this nice symposium. Enjoy the gala dinner, and hopefully we can see each other on the next conference. Bye!